Hi, my name is Matt and I'm a civil and environmental engineer, and my specialisation is in coastal engineering. Most of my work is with island communities of the Pacific, and it's really about working with those communities to understand the risks from coastal and ocean hazards, helping to build resilience to those risks, and as well just to climate change and the impacts that climate change will bring over the long term. So on the one hand, if we think about the main challenges for island communities like where I work, the main humanitarian challenges, most of these scenarios arise where we have people and communities interacting with their environment. And so the challenges are usually things, say, water scarcity for these communities, or in fact too much water causing flooding in some times. Or it might be things like access to potable water for drinking, or it might be wastewater disposal and how to do that safely in the surrounding environment. We can also have challenges from things like living in coastal zones, of atolls and that kind of area, and the challenges that that brings through sea level rise and coastal inundation. But what we can see is that more often than not, the humanitarian challenges, the key challenges, come about where we have people interacting with their surrounding environment. Then on the other hand, we have engineers, and we have engineers that are privileged to have been given this really unique set of skills. Skills to allow us to think critically about problems, to break a problem down and systematically work through that challenge until we can come up with a solution. It's skills that enable us to take data and information and incorporate that into our decision making, and to be able to think within a sort of a risk type framework. And engineers have been given all of these skills through the training that they're privileged to have. And if we think about civil and environmental engineers in particular, they take these skills and they apply them in situations where we have people and development, and we have the surrounding environment. So that might be, for example, designing infrastructure to withstand some sort of extreme environmental condition, or it might be working with natural resources and managing natural resources like coastal zones and things like that properly. Or it might just be using engineering type thinking and problem solving approaches to reduce risks from hazards on communities. But civil and environmental engineers have these unique skills that really come into effect where we have people and development working with the environment. So bringing those two pieces of information together, on the one hand, we have humanitarian problems that really focus on people and the interaction with those people and communities with the environment. And then on the other hand, we have engineers who are trained to use their specific skills to solve problems around people, communities, and the environment. And so what humanitarian engineering is really all about is bringing those two things together. It's the enabler that looks for the synergies between the problems, the humanitarian problems, and the skills that engineers can bring. And that's why it's particularly important. So engineers working at WRL, I guess because of the type of projects they're involved in, because of their mentoring, they usually have very strong technical skills. But combined with that, they're really grounded, and a lot of that comes from the fieldwork experience, the hands-on sort of practical side of the experience. Getting out, working at grassroots level, still solving technical problems and doing technical work, but really working out in the environment and applying those skills to sort of real world problems. And so that for me really embodies what humanitarian engineering is really all about. And so that's where those skills that engineers that come through the WRL's team, they really bring that to the table, that real world experience and that practical sort of ability to get out, get their hands dirty and solve problems in the field at a community level. For me, the journey into humanitarian engineering started when I realised the positive impact that my work could have and the large impact that it could have to enable communities in the Pacific region to better understand their risks from coastal and ocean hazards. For a lot of communities out here, in particular atolls, remote atolls and small islands, the risks that people live with every day from these kind of hazards are so much higher than what we would accept somewhere like Australia or New Zealand. But on the other hand, the amount of engineers that are out here applying their skills and their expertise to solve these challenges is quite low. And so because of that, coming out here and working really provides the opportunity to have quite a lot of impact and quite a big positive impact from the work that I do. These days I'm actually managing a large climate, weather and ocean science program. It's really focused around collecting better quality data both in and on the ocean, and weather and climate data as well, and bringing that information in to enable better decision making and build the preparedness and resilience of some of our island communities. The program really looks a lot at that data collection side of things, but also about early warning systems and building better systems to alert our communities when they might be impacted by a severe weather event. The work that I get up to on a day-to-day basis is super diverse. I could be designing an automatic weather station one day to be deployed out into an outer island and to help us understand what the climate conditions are there. The very next day, I could be traveling to one of those islands and working at a grassroots level to really communicate and help that community to understand how climate change might impact them in particular and their island. To talk with them about natural disaster events and climate disasters and how they can build their preparedness to those sorts of things.